Alright, 1.5, number 43. Here's our function. We're supposed to find the inverse and verify that f of f inverse of x is equal to f inverse of f of x, which is equal to x. Okay, so first thing I'll do is find the inverse. So we interchange x and y, and then a whole lot of algebra. So we just simply need to solve for y here. Simply, yeah, not all that simple. So I'm going to multiply both sides by this in the bottom. So multiply by 1 plus 2 to the negative y. So it's just x times 1 plus 2 to the negative y equals 100. And I'll divide by x. Maybe subtract 1. There's different ways of doing it. So 2 to the negative y equals 100 over x minus 1. Alright, so 2 to the negative y is actually 1 over 2 to the y. And I think it's going to make sense to combine these first. So 100 over x minus x over x. Now they have a common denominator. So I get 100 minus x over x equals 1 over 2 to the y. Maybe cross multiply. So it's 2 to the y, 100 minus x equals x. And divide by that quantity. So 2 to the y equals x over 100 minus x. And to undo 2 to the power, you have to do a log base 2 of each side. So we get the log base 2 of x over 100 minus x. Okay, so that's our inverse. Alright, so now we're going to verify that it is the inverse. So if it's the inverse, we should be able to plug this whole thing in to the original for x, and you should get x. So we'll try that right over here. So f of f inverse is 100 over 1 plus 2 to the negative that stuff. Boy. Alright, so all of this should be x. Okay, so we have a negative up front. One of our properties is if you have a number out front of a log, you can move it to the exponent and vice versa. So think of this as 100 over 1 plus 2 to the log of x over 100 minus x base 2 to the negative 1. We just moved it from right there to there. Okay, so the negative 1, it actually reciprocates it. So it's 1 over 1 plus 2 to the log base 2 of 100 minus x over x. And then log base 2 and 2 to the power are inverse operations, so those undo each other. So we get 100 over 1 plus 100 minus x over x. I've got a fraction inside of a bigger fraction. I'm going to multiply the top and bottom by that common denominator. So I get 100x over, distribute, I get x plus 100 minus x. And then the bottom, x minus x, cross off. Those are gone. And then the 100 over 100 cross off, so we get x. So that way worked. Then we'd have to plug this into our inverse for x, and you should get x also. But I'm tired of this problem, so that's probably good enough. And no, you don't have to do any more than that either.